Welcome to a new test and teardown video. This time I just got this funny thing here. I don't know if you can see how big it is. My table here is actually quite deep. I think it's 85 centimeters deep. Look at these things. So this is a turntable controller from about 1970 from an EMC lab, and it looks like it's a little bit home brew, but maybe not. Something those back in those days, all those EMC lab things, they were made in a very low volume. So everything here is of course written in Danish, and I will go through everything here, how it is made and all that. It is from a lab called Lab for Electromagnetic Field Theory. How about that? And this is their inventory number. We got a this is for a pen writer. So there's an output for this pen writer. So you apply 24 volts, and then this output here goes between 0 and 24 volts, depending on the angle. I bet there is a potentiometer somewhere that will do this. And then there is this is the input, I guess, to put the turntable into the angle. You can see here we got all the angles, and this is speed, where you set this, the motor speed maybe, or how aggressive this regulation is. We got a tachometer, amplification, some balance push button thingy. I don't know exactly what that does. The mains connector is this old 1960-70 style connector. We got oh, look at that, a rectifier here, selenium rectifier. We got some germanium diodes, old germanium type of transistors. Everything here is of course completely rotten, so I don't expect to be able to play with this. I am missing a motor power drive, so this is only the controller. And we got a really nice gearbox for the setup here, and there's a little weight. Look at that down there, to give it good, nice stability. This is a resolver or an encoder. We got 5 wires coming out of that one. Some capacitors, and oh, you gotta see the back here. Look at that circuit. It's not a circuit board in the normal sense. Oh, there's a little rectifier bridge or some other. Yeah, yes it is. Look at that. It looks like a upgrade at a later point, right? And old tech resistors and a few diodes as well. Well, and a really big transformer. Maybe there's a little bit of information somewhere written on this circuit board. I will of course dig a little bit into this one in a few minutes. This unit here is the thing I found really interesting. It is, I mean, it is 30 kilos. Yes, I just put the weight on it here. It is so heavy. You can barely lift this thing. Luckily, this piece of aluminium here is really thick and stable, so I can grab it like that. We got some really funny features going on here. And again, there is a special motor that drives this AC synchronous something motor. And look at that, we can even read. It's a generator something, 60 cycles, and then 115 volts or something like that, right? I mean, I need to take away this side panel so we can easier see what is going on. There's also a little box with some stuff here at the back, an N connector cable, and we got 3 cables coming out of this one. This is the connector that is mating with the control unit. And see, we are missing the power drive for the motor. And we got a little cable going all the way around, and the base is big solid iron, and all this here is super solid. We got the gear from the motor to a resolver, and I think this over here is the potentiometer. Down there is a potentiometer. We'll look at that a little bit. So this is the rotate plate for all the science experiments. So while this thing is rotating, you can have electrical connections to something using an N connector. So high frequency experiments in 360 degrees for all sorts of magnetic fields experiments. And I found that super interesting. How did they make this? Maybe you can... This we need to take apart and have a little look. What is going on? Maybe I can just unscrew this. And I really need to take down the weight of this massive thing because it's impossible to work with. So the side panels there are away. And this is the top rotation plate. Why have we got all this lubrication stuff going on here? That is weird. Got a tiny little bit of slip slap here. I think I want to clean all this so I don't get super nasty and all that. This looks like a... Oh, it's completely soaked. How is that even possible? But look at that. It looks like it's brass or copper or something like that. Why would you use something as exotic as that? And what is going on here at the back? What is the whole idea with all this funky stuff? Maybe there's another motor. Oh yes, there is another motor here at the back. Really? What is going on? So we got a motor here again, and then a generator. What is this for? So now I'm a little bit more inside this unit, but I really need you to see something. So I'm sorry, I'm holding the camera in a really weird angle because I only got 2 fingers to try and hold this. But I really want you to see what the heck is going on here. And I just touch this with my fingers, so there's some super slimy goo sticking out of this hole, and there's a little super slimy nastiness. So I think I need to clean this, or maybe this whole gearbox system here is fully gooed with some of this stuff, and it's dripping out of that side. Oh no, nasty. And this is why the whole bottom part here is a little bit sticky, slimy. So I have tried to polish this part. Look at that. I think this is either brass or bronze, something like that. It's a little bit funny with the marks right here. It looks like the machine that made the holes also made a mark that's round like that. This is a little bit funny. And I found something really cool as well. See, there's a gear ratio from this. I believe this one is exactly the same size as this one and as this one that is down here. And I removed the 4 screws here, and that means I can now rotate everything here by hand. And the fun thing is this geared ratio. You gotta see this little detail here. So there's I bet this is a potentiometer or a resolver or something like that, but it gotta be the potentiometer. But what I really want you to see, look at the shaft on the potentiometer. Let's see if we can get some light. So if I go one way, see, now it's moving, and then you can even hear the potentiometer move, right? And then suddenly, I think it's a 10 turn or something like that, right? It's still moving. Oh, no, it's not moving anymore. And then I go back, and then it goes click. Now it's moving. See, there's a stop. And then click. It's skipping this stop. So there's a mechanism. See? So there's a mechanism and a little spring-loaded flip down in a little hole in the shaft kind of thing that will flip out if the torque gets too high, so they don't destroy the potentiometer. See, this is for the pen plotter output. So this is just a potentiometer used for nothing else. This is the resolver used for the position feedback and for the regulation loop and all that kind of stuff. And then there is this extra output we have seen over here. This is they call this Synchro something. So this is an output used for something completely different. And I believe this is just a 115 volt AC generator or something like that, because it says Synchro generator. And a lot of funky stuff here. So I bet we got, see, quite a lot of phase wires going from this one here, and this is just an output. I will maybe take this out and see how many wires and how many volts once I get this up and running. Here at the back, I find this really, really funny, special looking motor. And it looks like, you can see, two different motors with different resolutions. Yeah, I try to clean the contacts a little bit. But you can see the distance here and the distance in there. It is different. And at the moment I got 30 volts going on here, so let's try and turn on. And look at that, it spins. So 30 volts and 50 milliamps is 1.6 watts, and it spins real nice and fine. So of course this motor, this is the connections to maybe one of the motors, maybe this is this, and then there's another motor in here, I bet. So we got two different motors for two different speeds or torques or whatever. I don't understand exactly what is going on here, but that is how it looks like, right? So in here we got a normal gearbox. See, everything is just gear, gear, gear. And then in here, look at that. This is a worm gear or in here. So this one rotates with a round gear. And then there is, of course, teeth on this part that rotates in here somehow. I don't want to take apart everything here because I'm never going to put this, I will never be able to put it back again, right? So down here is an end connector. And this end connector, there's a cable that comes out. See, if I move this, yeah, here we go. So this is just free, and this is of course the end of this little coupler, and I was able to take it out. So this one just goes out, dip, 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 dip. And look at that one. Sivers Lab, made in Sweden. And here is the type number. So this is an endless high frequency N to N. And look at that, I can just take it here. And there's zero slap. See, if I take it here and just try and push it in any direction, there's zero slap. And it also goes a little bit tight, but not too much for me to handle like that. I believe this one is full of ball bearings and slip rings or some really fancy things. So how did they make an RF coupler with slip rings and 50 ohms in and out for high frequency stuff. I think this is a really cool component. So now we are running at 60 volts. Let me stop this noise, but I really want to show that I have connected the motor to everything, and I'm playing with this fantastic generator unit here. Because I don't have anything that connects to this one, I might as well just remove the connector and play with the wires. We got 5 black wires coming out of this one. Let's just remove these 2 and explain what is going on here. Those 2, we got, I think it was 36 ohms between these 2, and they are not connected to the other 3. So what I got here is I connected an oscilloscope just to a random 2 of these, because those are of course the 3-phase output from this generator. The single wire here is the magnet. So there is you need to apply a DC current to a magnet, and this way when the rotor spins the magnet, now it generates a 3-phase signal. I'm just showing 2 of them. And look at that. Here on my oscilloscope we can see the output voltage of those 2 windings. So that is a little bit funny, isn't it? I don't think I want to use this part of the circuit anyway. I want to focus on to try and see if I can get this stuff to regulate or anything like that. That could be real fun. And here is the bottom of this very interesting motor system. And see, here at the bottom we got the A2 connection, F1 mark and F2 mark connections as well. So remember the top windings. On the top side we have an F1 and F2 and A1. So all this makes up for this motor, and also here we can better see the different resolution of the connections. So that is a little bit interesting what is going on here. See, that is the end connector looking brand new and the other end looks like that. It's really nasty, sticky. So there's a way here to pull it out of this hole. And also we can see the little gearbox here at the end before it goes into this worm gear type of system. So from this angle it is easier to see the potentiometer. And it was exactly as I imagined, just a regular high quality 10-turn potentiometer. And here is this position resolver, and they call it the OS 1677, the AP 2-inch max slip transco Mark 1, and the MU number, and 50 volts something with 7M, and then 50 AC. Yeah, that is a cute part. And here at the back we can see all the connections, but it is difficult to focus on all the different wires that goes into this unit. I am trying to get this top part away from the base plate, and to be able to do so I had to build a little special tool because of those screws. See, I had to make this one. So I was finally able to pull away the bottom plate here, and my god, that is one solid piece of steel. It's very heavy, and I think the rest here is probably aluminium, so that is why it was so heavy, that plate. Anyway, this bottom part here, this is where the cable went through, and you can do of course all sorts of funky things with this rotation unit, but I think this piece of metal here just goes all the way through like this, and I still haven't figured out how to pull away the top mechanical parts, this one that rotates and all that, but I see this screw right there. Maybe this is what locks everything in, and there's probably another one on the other side. But how do you access that screw? I think I am super close to giving up assembling or disassemble everything here, because I really need to understand how to assemble this and disassemble it so I can service the inner parts of the main rotor, and I can't get it out. And I think this screw here is the locking for all that. This seems possible. And this screw here is the lubrication exit. So you open this screw and then you open this one, and then you fill everything up with grease, and then when it splats out this hole, you are done. So I can put this little screw back in here. I just checked how that works. But anyway, I really wanted to show this really cool multi-turn potentiometer little hack they did here. So they milled this little groove in the shaft, okay? In here, see this mechanism, there's a hole. So what I took out here is a set screw, a spring, and a little steel ball. So all these things goes in here, and then you can imagine by tightening the set screw to the exact torque required to push this little groove in here, and then the ball sits up there. Now you have exactly what is required to spin it normally, but when you hit the end stop, it's just gonna flip over until next try, and then you can go back again, and this way you have your plotter output, and you are still free to move any number of full turns. How cool is that? Of course I can take out this screw. I just needed a much bigger screwdriver, but look at that. This is the kind of grease we got. It turns itself into all sorts of nasty goo, and look at that, we got all sorts of funky particles in it, and some wet and some slimy. This is not how it's supposed to be. So how do I fix that? Oh, it's full of metal as well. Nasty. So let's go back to the control unit now that we know how the entire motor unit works. And I think we now know that this connector here is both for the motor and feedback and all that, and this output here is just for something external. That means there is a chance that I will be able to run and rotate and control everything with this one in case it works. But I really want to show a little bit more about the mechanical build quality of this unit. And look at this. I don't know if you can see the distance here, but it is, I mean, less than a hair distance, and it's not touching. How nice is this made? And also the print, the labels you see here. Do you know this piece of thin aluminium sheet with self sticker on the back? And then it is you develop this with UV light and some acid or base or something like that. And you can even see the print here is done using a plotter on a transparent film. If you look real careful, it is actually possible to see the fonts. They are done using a plotter. And the idea is they are, of course, made in a very low volume. But I'm just really impressed about the build quality. You can also see in here, this is the same, done by a plotter, and the numbers, and so this in here is the same material as the labels we see anywhere else. And that makes me believe that this is a one-off or a few-off control unit, and this is more like a unit you can buy somewhere and they added some labels to it or something like that. So that's probably what it is. So the first thing I always look at, that is the fuse. And this one is a 1 amp, but look at that, radio parts. And 1 amp, and it is intact. So this tells me a little bit about the power consumption we should expect. So let me put this one back again. That seems to be a little bit impossible. And look at those thin, flimsy wires. And also chassis connection is not a thing. This type of connector here, they come in chassis protective earth, and also this one that's completely isolated, which I really don't like, because if there is something wrong in here, I could get a nice and nasty electric shock, and I don't want to do that. So I always want to ooh, this one is broken, but it's still gonna be okay for that. So this one is connected directly over the mains input. We have a 50 volts output, and we have 40 volts. So that tells me a little bit about the motor speeds. I was hoping to find some information about if the mains voltage goes somewhere to some rectifiers or something like that, or is it only the secondary side? I really want to know that, because I want to know what is the voltage level to expect. We got some filter capacitors, resistors, and all that kind of stuff. This rectifier here, and then we got this old, very rusty, funky looking controller, and that is built in a completely different way compared to the rest of the unit. So that tells me a little bit as well, right? Oh, we got a little epoxy-coated component here, like a little integrated circuit. And there's another one down there, also epoxy-coated. Oh, we got some more funny looking transistors, and oh, look at those transistors there. This tells me the age is 1965 plus minus 5 years. So I think that is a very good guess. You are, of course, very welcome to participate in the guessing. Let's see if we can find any more clues. Maybe on those capacitors, if I pull these out. But I think I just want to power it up and see what happens. See, those are connected to the same resolver AC wires as this one, and then there is another signal that is connected here, and then the difference signal here is amplified and drive the DC ACDC motor, because we got many windings. It can do AC and DC modes, this motor, so it's really interesting. Yeah, let's find the cable and see what happens. Just realized one thing I think that is important to mention, and that is this little logo right here. It says FFI and 1959. So this tells me when this, at least when the circuit board was designed. And by the way, look at this circuit board. It looks like it's 3 millimeters or even more. The thickness is just amazing. So I've connected this big, thick, massive cable with my control unit. I also put in 24 volts for the DC output for the plotter, just to see how that works out. And then let's just start by turning up the power real nice and slowly. This is, oh, it's already driving. It's already driving. Look at that. Let's give it some more. and then it stops. Oh, that is probably not good. Oh no, but something did happen. I could hear it was shorted, something was shorted. Let's try and crank it up again real slowly while we'll look at the current consumption. Yeah, this is probably not good. It's not running at all anymore, but it's using a heck of a lot of power, and I can hear that something is not good. Oh no. Well, what did I expect? Figured out it has something to do with the voltages and the ranges and the speed. So now we're going to turn it on at much higher voltage and see what happens, okay? And here you go. So it's working so far pretty good. And it is, of course, turning around. Let's see if there's any. No. There's no sensor feedback. I was expecting this one to feedback and then go into well, that is just how it is. Bad luck for me. And it, oh my God, it smells burnt somewhere. I hope I don't get anything up in my face. I better open the windows now and figure out what is warm here. So I took out the control unit just to see if there's anything I can do. I don't have any schematics, and it is actually a little bit more complex than I first anticipated, because look at that. It's full of little black old germanium transistors, quite a lot of them actually down there, and many layers, and also power transistors in here and here. We got some power resistors down there, and we also got those really funny modules. They potted some epoxy in there. You can almost see there's some stuff going on in there because it's a little bit transparent, but there's not much I can do about this. Oh, look at that. We even got some more power, medium power transistors in there. So I think I will just put this back into my storage for now, because there's not much I can do for this right now. I don't feel I want to fix the controller unit as it is, but I do think this motor unit is super cool and nice, and I will definitely find some fantastic usage for this, including the turntable with the end connector things and all that. I think that is so fantastic. So I think I will call this a day and say thank you very much for watching. Hope to see you soon again. Bye bye.